In this video tutorial, we shall see the logic as well as the assembly program for implementing a 16x8 multiplication. Now let us see what are the options available in the instruction. So we have the instruction mul AB. So what does this instruction do? It multiplies the content of accumulator with the contents of register B, right? And when you multiply two 8-bit numbers, so we get a 16-bit product, right? Let's say the product is YY and XX. So XX is the lower byte of the product and YY is the higher byte. So how is this result stored? After the multiplication, register B, this contains the higher byte of the product, and register A, it contains the lower byte of the product, right? For examples, let us say I am multiplying 90H into FFH, right? So how much is 90H into FFH? Let us see that. So 90 into FF, it is equal to 8F70, right? So 8F70. So register A will contain 70H and register B will contain 8FH. So this is what is being provided in the instruction. But now the question is, we are supposed to multiply a 16x8 number, right? And the width of our registers is only 8-bit. So for this, we need to find out a logic. Okay, so what will be the logic? Let us see. Let us consider an example, right? Let's say I want to multiply 1, 2, 3, 4, which is in hexadecimal, which is a 16-bit number, with a 8-bit number. Okay, it may be anything. Let's say it is 92H, right? So what is the result I should get now? 1, 2, 3, 4 in hexa multiplied by 92H. So what I am getting is 0A, 61A8, 61A8 in hexadecimal. So it means if I multiply a 16-bit number with a 8-bit number, right, I get a 24-bit product. What I get is a 24-bit product, right? So this is what is expected in the result now. Now how is the logic? In the first step, first the lower byte of 16-bit number, it is multiplied with the 8-bit number. Okay, so that is the lower byte is what? 34H. So 34H into 92H, right? So if you multiply 34 with 92H, let's see what we get. 34 into 92. So I got 1DA8. 1DA8 in hexadecimal. Then I will take higher byte of 16-bit number with a 8-bit number, right? So the higher byte is 1, 2 into the 8-bit number is 92H. So how much is 1, 2 into 92? 1, 2 into 92. It is 0A44. 0A44H, right? The third step is I will add these results. Addition of these intermediate results so that I get the final result. So how do I add this? So from the first multiplication, I have got 1D A8, right? So this is added with 0A44, right? So this is how we add, right? So if I add this, I will get A8, right? Next, I have to add 1D plus 44. So there is no carry. I got 61, and this 0A will be as it is. So this addition may generate a carry. Okay. So let us check whether it's same. You can see the result is 0A61A8. So this is the logic. Take the lower byte of the 16-bit number, multiply with the 8-bit number, then take the higher bit of 16-bit number, multiply the 8-bit with the 8-bit number, then add the results. Now the most important here is that how you store the numbers, right? So you should store properly. Okay, for example, let's say I have the memory starting from 30H. Right? So this is 30H, 31H, 32H, and 33H. This is very important. Okay. I am planning to store my 16-bit number in the first two locations. How do I plan? I should know that. Okay. So the number I have considered is 1, 2, 3, 4. Right. So I will store the higher byte in 30H, and I will store the lower byte in 31H. You can store either way, but you should know. So this I will mark it as higher byte of 16-bit number, and this I will mark it as lower byte of 16-bit number, right? And the 8-bit number, that is what we are multiplying, 92H, that I will store in memory location 32H. So this is my 8-bit number, right? So this is very much necessary. So this will make your programming easy. Then how will I store my result? I am planning to store the result in this way, right? I will store the result in R5, R6, and R7. Okay. In R7, I will store the lower byte of product. In R5, I will store higher byte of product, right? And the mid byte I will store in R6. It means as per our result, 0A will be stored here, 61 will be stored here, and A8H will be stored here, right? So this is the logic, and this is how we are planning to store. You are free to store the data wherever you want, but you have to program accordingly. Okay, so let's write the program for this. So the first is I have to take the lower byte of the 16-bit number, move A comma. So where is that I have stored it? I have stored in 31H. So move A comma 31H. So this is lower byte of 16-bit number, right? Then this I have to multiply with the 8-bit number. So this is my 8-bit number, right? So just multiply. That's it. Okay, so the first multiplication is over. Now where should I store the result? I am planning to store in R6 and R7. So whatever the lower byte of the product I have got, that is the final result. So I will store in move R7 comma A, because A contains the lower byte of the product. So this is lower byte of product. and the intermediate result I will store it in R6, that is in B. So this is intermediate result wherein I have to again perform the addition. Now I have to perform the second multiplication, so I will take the higher byte, that is in 30H, higher byte of 16-bit number, then move B comma 32H, that is the 8-bit number, then I will say multiply AB. So this is my second multiplication, right? Second multiplication means this 12H into 92H, right? Now what I should do is I have to perform this addition, right? So 1D, it was stored in R6. Now after this multiplication, 44 is in accumulator. So I have to add 1D and 44. Okay, so 44, 1D, that is the previous addition, is in R6. So I will say add A comma R6, right? And after addition, I will put back the result in R6. So move R6 comma A. So this is mid byte of product. Now where is the last byte of the product? That is in register B. Okay, so this addition might have created a carry, right? So for that, what we have to do is, so I will copy that into accumulator first, move A comma B, then I will say add with carry A comma hash 0H. Okay, what does it mean? So if the previous addition had generated any carry, so that will be included and added with the higher byte of the product, right? And after this, I am planning to move this result in R5. So this is higher byte of product. Now as you can see, if this representation is clear, you can easily write the program. Okay, and even if you have done any mistake, in step-by-step execution it will be clear. Okay, so let us do that now. The second important thing is, whatever you have planned, store the same thing. So 1, 2 in 30, 3, 4 in 31, and 92 in 32H. So let us multiply. First I will read the lower byte, that is 34, then the 8-bit number. So I did the multiplication. I got 1D A8, which is nothing but this one, the first multiplication, right? And this I am storing now, right? A8 I will store in R7, right? And 1D I will store in R6. Then I will do the second multiplication now, that is the higher byte of 16-bit into 8-bit. So higher byte is 34. So 34 is in accumulator. The 8-bit number is 92H. It is in B. So if I perform, I got 0A44, right? So this is what? 0A44. Now I have got both, right? So already I have stored the lower byte. Now I have to perform this addition. So for that, the previous result was in R6. So I am adding, R6 contains what? 1D. So this should be added with the lower byte of the second multiplication result, that is 44. So if you perform, you get 61, and I am moving back the result to R6. So R6 contains 61. So this addition might have generated a carry, right? So that I am accounting with this instruction. So I copy the higher byte, that is A. So there was no carry generated, right? So that's why 0A will be 0A itself in accumulator, and the result is copied to R5. So if you see the contents of R5, R6 and R7, it is 0A, 61, A8, which matches with our result 0A, 61 and A8, right? So this is the logic of 16 cross 8 multiplication.